Here's our cheat sheet for motion graphs. The key here is remembering that slope is rise over run, or change in y over change in x. So the slope of each graph really gives us information about the next graph. A distance versus time graph, the slope of that is rise over run, change in y over change in x. Well, look at the axes. The y is distance, the x is time. Distance over time is equal to velocity. So the slope of a distance versus time graph tells us the velocity. Let's say that our slope, or that our distance versus time graph looks like this. The slope is increasing as that line curves upward, which means slope of distance versus time graph is velocity. The velocity is increasing. Well, if the velocity is increasing at a constant rate, then the velocity versus time graph is going to look like that. Slope is, again, rise over run, change in y over change in x. Our y in this graph is velocity, x is time, so change in y over change in time is change in velocity over change in time, and that's acceleration. The slope of a velocity versus time graph tells us the acceleration. In this case, the slope is constant, which means the acceleration is going to be constant. This, whatever this is, a runner, a car, a bird flying, they are accelerating at a constant rate. They are increasing their velocity at a constant rate. Now if we look at the other side of the cheat sheet, right here we have some if-then statements, some more examples. If the distance versus time graph is a straight line, that means the slope isn't changing, so the velocity isn't changing. So the velocity graph is a flat line. The velocity is not changing. It's at a constant velocity. If the velocity versus time graph is flat, that's what we finished with up here, then the velocity isn't changing. The slope is 0, so the acceleration is 0. If the distance versus time graph curves upward, that's what we drew on the other side. The slope is increasing, which means the velocity is increasing. So we show the velocity versus time graph increasing. It's going to be increasing, showing it's a straight line upward. If a distance versus time graph is flat, that means as time goes on, the distance isn't changing, the position isn't changing. So if the position isn't changing, that person or that airplane or that bird or that car isn't going anywhere. Their position isn't changing, their distance isn't changing, so their velocity is 0. Let's look at some more examples right here. So here are situations right here, and looking at those situations, we want to be able to draw the distance versus time, velocity versus time, and acceleration versus time graphs. Notice that the acceleration x-axis is in the middle. That's where 0 is, because acceleration could be positive if that object were speeding up, or it could be negative if that object were slowing down. So first one, if we have constant velocity, it's moving at a constant speed, that means that maybe we could draw this one first. The velocity isn't going to be changing, it's constant. The slope isn't going to be changing on the distance versus time graph. It's a straight line. Slope isn't changing, slope is constant, velocity is constant, so acceleration is 0. If we have constant velocity in the opposite direction, we don't really use this situation a lot, but it's going to be the same except that we're moving in the opposite direction. Still constant velocity, so there's no acceleration. Acceleration is 0. If we have increasing velocity, we're speeding up, we're getting faster. That means the slope on our distance versus time graph is increasing, it's curving upward. Our velocity is increasing, because as the slope increases, the velocity increases. And the slope on the velocity versus time graph gives us acceleration. The slope is constant and it's positive, meaning that the acceleration is constant and positive. Okay, if we are slowing down, our distance versus time graph is going to show a slope that's decreasing. So it's going to start steep and get shallower, 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 shallower. Our velocity is decreasing, slowing down, and that goes along with our slope decreasing. Our slope is getting shallower, so our velocity is decreasing. And if we're slowing down at a constant rate, this is still a straight line for velocity versus time. So it is constant acceleration, but it's a negative slope. It's slowing down, so it's going to be a constant but negative acceleration. Okay, and here now we've got 3 different parts: slowing down, stopping, speeding up. So I'm gonna kind of split my graph into 3 parts here. Showing those 3 different portions, those 3 different sections of movement. So first, if we're slowing down, we know that the slope is gonna be decreasing. It's gonna be getting shallower, so it goes from steeper to shallower. Then if it's stopped, that means the distance or the position is not changing. So whatever our distance is at, right here we're at 1, 2, 3 squares, it's gonna stay at 3. The next part, which says we're speeding up, so it's gonna start shallow, but get faster, faster, steeper, steeper, steeper. Slope is increasing. On the velocity versus time, as that slope decreased, that's because velocity decreased. In the middle part here, if we are stopped, we're not moving, well, velocity is going to be 0. And if we're speeding up, velocity is increasing. For the acceleration versus time, when we're slowing down, we've got a constant change in velocity, but it's slowing down. It's going to be a negative acceleration. If we're stopped, we're not going anywhere. We're not speeding up or slowing down, so our acceleration is 0. And then as we're speeding up, velocity is increasing. This is a straight line, so slope is increasing, or is constant. So it's a constant positive acceleration. And then here's our last one. Again, we've got 3 different parts to this. So I'm going to divide my graph into 3 again. So I can just keep track of those parts matching on each of the graphs. Okay, first part, speeding up. So my distance versus time graph should get steeper. It should be curving upward. Then a constant velocity on a distance versus time graph is a straight line. So a constant slope. Then slowing down means that slope is going to start to get shallower. The velocity versus time graph, if the slope is increasing, it's getting steeper because it's getting faster, then velocity is increasing. In the middle, constant velocity means whatever my velocity is at, it stays the same, it's constant. And as I'm slowing down, my velocity again is going to decrease. The acceleration is going to show that as that slope is constant but positive, the line is going upwards, it's going to have a positive acceleration. This object is accelerating, is speeding up, increasing velocity. Then at a constant velocity, the acceleration is not changing. The velocity is not changing, so acceleration is 0. As velocity decreases, it's slowing down. That means acceleration is negative.